Okay, so after working this out, you get 6 kilometers. Okay, rounded. Now, that's the magnitude, right? Now, we need to figure out if this whole angle here is 40. Okay, so in this diagram, it can be clearer. From here to here is 40 degrees. Okay, so from the north line to here is 40. If I can figure out this angle in my triangle, then subtract it from 40, I can find this unknown, which is what I need for a quadrant bearing, right? I need it from the north line. So in this diagram, I need this tiny angle in here. And so if I can find the angle inside my triangle, I know that that angle plus, or that angle plus the unknown angle should add up to 40 degrees, and that means I can find the unknown angle. Okay, so let's call this V, okay, since my vector V is across from it. Let's call this R, and let's call this U. So let's use the sine law to find V. Now, I know my R is 6, and I know my angle there is 125, so I'm going to use R and not use anything with U. Sub in all your values and cross multiply. Okay? You end up getting 6 times sine V equals 4 times sine 125. And sine V is equal to 4 times sine 125 divided by 6. Therefore, V is going to equal the sine inverse of, let's see what this decimal is, 4 times sine 125 divided by 6. Okay? I carried quite a few decimals there just to increase my accuracy. And our final answer then is 33 degrees. Okay. But that is just the angle inside my triangle. It's right there. If I want to find what's missing, I simply need to do, let's call it theta. Theta is equal to 40 minus 33, which is actually 7 degrees. So therefore, my final answer is 6 kilometers north, 7 degrees towards the east. Okay, that's that tiny angle in here is 7 degrees, which makes sense. I mean, my diagram seems pretty accurate, actually, with respect to that. Okay, that does it for this lesson. So to summarize, I mean, you're going to use trigonometry. You're going to be adding vectors, drawing them head to tail. You've got to have a pretty good knowledge of finding quadrant bearings, okay? And you're going to be using cosine and sine law for pretty much all of these questions, okay? Unless it's a right angle triangle, in which case you use your primary trig ratios or Pythagorean theorem.